Okay. All right, so let's begin. So first of all, I want to say that there are 3,000 people who joined the event, and these are great results, and this really shows the interest in this technology. And the question is, why do we need this event, right? The reason for this is right now all the field of neurotech is driven by research, driven by medical industry, driven by wellness applications, and these are important. These are important industries. But if you look around yourself, most of the technologies were brought either by military advancements or entertainment. So it makes sense to look on entertainment as a means of advancing technology, and we believe that brain-computer interfaces or neurotechnology in general, the future is of this technology will be driven both by medical industry and the gaming industry. And so the reason for this event is to show that there are already leaders in this field, and that this field will be growing and getting much more followers in the upcoming future. So we have a very, very special event for you. Thank you for joining. And let me introduce our host today, Yannick Roy. Yannick.
Hi, everyone. So I'm super excited for this event today. We do have a lot of registrations, so it seems to have a big reach and audience and big interest. So my name is Yannick Roy. I'm co-founder of Neurotech X. I'm passionate about gaming and neurotech, so this is the perfect event for me. So I'm glad to be hosting it today. So just quickly, what is neurotech and gaming? Just to make sure we put the table for what we can expect today. So we're going to go in different area of neurotechnology. So neurotech means brain, nervous system, anything related to that with technology, and gaming. So it could be really broad. We'll explore some of the feedback, haptics, some of the more EEG, BCI related technology. So we'll navigate in different era. Once again, this is not a lecture. This Neurotech X aims to put a framework for discussion. We have hundreds of participants here today. So please share your knowledge, questions. It's really a community event, so it's not just us talking. So participate as much as possible, ask questions, engage. If you have resources to share, interesting either games, projects, technology, research, please by all means contribute to make this event a greater success. So I'm going to introduce Neurotech X a little further, but right now I would like to let Mike Embinder to start from Valve, who's a principal experimental psychologist as well, with a background. He did his undergrad studies in computer science and psychology, and then a PhD in psychology, and has been at Valve for more than 12 years as principal experimental psychologist. So I'm super excited to see that he's got that much experience in the field. So his talk is brain-computer interfaces, one possible future for how we play. So if you want to take it away, Mike, I'm going to stop sharing my screen and you can share yours. Oh, good for the screen sharing on your side?
1 second.
So in the meantime, if I don't know if the audience or during Mike is sharing his screen, I don't know if most of the audience have seen recently one of the founder of Valve, Gabe Newell, gave an interview and talked about we're way closer to the Matrix than people realize in the interview. So there was a famous quote as well. I hope I'm not burning any of Mike's material, and I might be actually. So if you haven't seen that interview from the founder of Valve, that is definitely an interview to watch. But I'm sure that Mike will convey some of the idea here today and his vision since he's been in the field for quite a while.
Yeah, is that working? Here we go.
Oh, I think we're.
We got it?
Yep.
All right, sorry about that. All right, I can get started. Thank you everyone for coming. Again, my name is Mike Amender. I'm an experimental psychologist at Valve. I guess at Valve, I work on applying knowledge and methodologies from psychology to game design, and do a bunch of data analysis as well. But more recently, I've started looking at brain-computer interfaces and doing research into them, and kind of in the hopes of seeing what's possible and how it might lead to one possible future for how we play. So the question that motivates our interest here, right, is really the following: how you interact with technology in 10 years. What is actually the future of computing? What comes to mind when you think about entertainment in the future? Is it going to be advances in mobile technology, VR, AR, will be screens everywhere? Or is it going to be something where maybe if we're measuring physiological data and using that as inputs to pieces of technology, maybe we can kind of foster or create a new way of interacting with technology that's kind of an improvement over, current generations. And so for us, when we think about how things are going to change over the next 10 years, we're very interested in what we could do with brain-computer interfaces. We have three primary motivations for our interest in BCI. And in this talk, I'm going to talk about the first two, about improvements to our playtesting processes and how we can design gameplay that adapts in real time to what players are experiencing. And I'm going to, we also are interested in kind of like the long-term replacement of traditional interfaces with, more BCI-based approaches that people think of when they refer to as true BCI, where you think a thing and it happens, and that's very far away. But we're aware of it, but our focus here is on how we could potentially improve our playtesting processes and become smarter game designers, and how we can design adaptive gameplay. And so I'll focus on that in this talk. So just to get everybody on the same page, here's my definition of a BCI. I'm sure a lot of people watching will have better definitions, that's fine, but just so we're all kind of working together. For me, it's a communication pathway that translates neuronal or neurological signals into actionable input for an external system. So really, you have any measurement device that is recording some sort of physiological data. It's interpreting, classifying that data and conveying it to a piece of technology. And then the technology uses that information and produces a response, and off you go. And so for us, the kind of fundamental question we're after is what changes when we incorporate information about a player's internal state into our game designs. Right now, gameplay, with traditional games, you have information that's conveyed through a mouse and a keyboard, a gamepad, a gesture, but that's it. And our hope is that, okay, if you incorporate information about what a player was actually experiencing or feeling, that maybe game designs could change. So this is the thesis we have and what we're kind of operating under. So, and to kind of, maybe kind of further expand that point, this is an analogy that I find somewhat useful. And so think about what happens when you have a conversation with folks. There are both verbal and nonverbal information that is conveyed in the conversation. So verbal is, the words that you say, and then nonverbal is maybe your tone of voice, whether you're being sarcastic, your posture, whether your arms are folded, maybe any prior context that you bring to the conversation. But the conversation, like the sum total of information in the conversation, is composed of both verbal and nonverbal information. And so right now games, are composed of, traditional inputs, again, what you get through the mouse and the keyboard, gestures and whatnot. And the question that we're after is, what happens when you add in physiological data to the mix? And the hope, the theory, is that you might be able to create new kinds of games. And so that's kind of what we're after. And so it leads to this question. It's like, what about all the data that we're missing from the player's experience? When players are playing our games, we know what they're trying to do in game for the most part, but we don't know how they're experiencing it, right? Are they happy? Are they sad? Are they engaged? Are they detached? Are they challenged? Are they bored? Are they frustrated? Are they curious? Are they exploring or solving puzzles or goofing off or playing seriously or playing frivolously? Are they remembering something? Are they speaking to a friend? Are they getting angry? All these questions that we don't have data to, that in theory could be pretty useful to us as game designers. We may not need any of it, but I guess I'm giving you a talk about why we think we might, and why it might be interesting to try and find out what we can uncover, what we can, and how we can improve gameplay when we have access to this data. And so the theory here is that we get an improved player experience when we have access to internal states and emotion and cognitions and decisions. And so the hope is that we can, turn all of this data into something useful and something, like a qualitatively different kind of experience that is much more enjoyable for people when they're playing our games. just the kind of, like the reason I guess that, or one reason that our interest in this has kind of increased is that, there's more and more research these days being done about the kinds of things you can measure, with, various, current generation sensor technology. Here's a list of, these are all examples of, findings with EEG where people are actually able, in the lab at least, to measure things like learning or surprise or novelty or excitement, relaxation, positive and negative emotion, intention, engagement, boredom, learning a concept or someone's ability to learn a concept, how people respond to stimuli in their environment. And we're not always getting all of these signals reliably, but we're starting to figure out how. And so, if we can do this in the lab, our hope is that we can then, take, some of these findings and start, applying them in the real world into gameplay, right? And measuring these same things with, existing technology and seeing what comes of it. So I mentioned that there were kind of like, at least for this talk, two main reasons why we're interested in using BCI-based approaches. The first is playtesting. It's a picture of me playing Team Fortress, one of our games. And the reason that Valve, to the extent that you like Valve games, the reason we make good games is because we playtest. We every game design we have is a hypothesis, and we put our game, put those game designs in front of people who are not us and gather data and iterate and improve the game as a consequence, right? So essentially, the playtests are the experiments we run to acquire knowledge about what's working and what's not. And so it is the foundation of how we make games, and if anything we could do to improve that practice will make us better game designers. And there are, with playtesting, there are traditional approaches. Direct observation is bringing someone into Valve and we watch them play the game. We can ask them questions. We can do surveys. We can obviously measure measure stats about what's happening in the game, and that can happen on the player base at large. And then there is a field of kind of research called usability that tries to kind of analyze how people interact with technology and interfaces in gameplay. We use those techniques too. The current approaches are great, but there are downsides. If you ask people questions, for example, people can rationalize and bend. They can confabulate. They can forget things. We can only measure, the things that we're actually recording. It's sometimes hard to know why things are happening. We also lack moment-to-moment insight. Excuse me. You can't stop a playtest and ask someone moment-to-moment, oh, how are you feeling now? How are you feeling now? How are you feeling now? It's not practical, right? And again, we could bring people into Valve, as many as we can, but doing it on large sample sizes are impractical. Maybe we could playtest hundreds or maybe even 1,000 over a long period of time, but we can't playtest tens of thousands or hundreds of thousands or millions of people. And the larger the sample size you get, the cleaner the data you have. Some things you obviously don't need a large sample size for, but some of the more sensitive things, it could be of use. And so these are some downsides. Not exactly, there are definitely more, but just these are issues that we run into as we playtest. And so, with BCIs, here are 6 ways at the moment that I think BCIs can kind of provide more information. And I'll walk through each of these but really quickly. We, in theory, could get moment-to-moment insight into what players are experiencing. We can get more objective data. We can do it at scale. And we get new kinds of data, like data we didn't have, we don't get through current playtesting practices. And we can track changes in this data over time. And then we also get to use it to augment our existing systems, right? It's not a replacement for our current playtesting practices. It's a supplement. It just, in theory, makes us smarter, we hope. So let's start with the first, moment-to-moment insight. The goal here is that, or I guess the hope is that we could actually get a real-time understanding of a player's emotional state, moment by moment, and second by second. We can get a response to individual components of gameplay. Right, so think about that for a moment. We could understand how a player reacts to a specific enemy, or a chat message, or a bullet, or them dying, or them getting a kill in a game, or choosing a character, or a piece of art, or a piece of the environment. We start eliminating gross responses. So like, oh, did you like this game? Yes. Well, why? We start determining the components that lead to the overall impression of what's going on. So we get to ask a question at every moment of the playthrough, and we get an answer without interfering with the experience. And I think that's spectacular. At least for us, like I'm very optimistic about, just in real time, getting a sense of how players are consuming our game and understanding, experiencing our game and what they're feeling. We get more objective data, right? So, you ask people questions, and so any internal sensation they feel is we're removing, their interpretation of the reactions. As a psychologist, I'm happy to walk people through all the reasons why people are not always great at illuminating or elucidating why they do what they do. But with BCIs that are hopefully more objective, we get less distortion and creativity and rationalization in their response. We could know if someone was truly feeling challenged instead of just hoping they are if we ask them. So instead of trying to induce a particular emotion in gameplay, like fear or excitement or surprise, happiness, sadness, we could actually know. Like as a game designer, like, hey man, we really want this to be an enjoyable moment, or a sad moment, or a confusing moment, or an illuminating moment. And in theory, if we can apply these techniques, we could figure that out. We also get, we get to do this at scale. So, all the advantages of watching somebody play your game internal to Valve, we can start, kind of running playtesting experiments on everybody who's playing the game, right? On hundreds of thousands of millions of people, if, assuming that, consumer grade technology or consumer grade versions of this technology exists, right? And so there is a chicken and egg situation here where, the benefit to customers has to be worth whatever cost investment there is to get the technology out there. But if it works and if it improves things, then yeah, we get to play this on everybody. We also get new kinds of data, right? So data we've never had before. We're no longer limited by the behaviors we can explicitly measure. We can start trying to infer rationales behind behaviors and say, oh, this was a positive response or a negative response. And we know it, oh, okay. So now we know that for this player, these are the things they like and these are the things they don't. And that makes us smarter. So we get more accurate measures of overall sentiment and more granular measures of individual sentiment instead of gameplay components. And we can start answering game design questions and assertions with actual data. So like, as a player, do you like melee or range combat? Do you like big explosions or small ones? Do you like health kits or collectibles? We become much more knowledgeable game designers. We can start validating our hypotheses. So maybe we can predict when someone is about to quit, both the game session and maybe forever. You could better understand game balance, or see if forum responses correlate to overall player-based sentiments. Are the comments on Reddit, are they reflective of a loud minority or like the actual majority? We could better understand impressions of a new weapon, a character, a cosmetic, a map, a game mode. We could figure out what parts of an update people enjoy, or figure out how they feel about the game's interface. We could identify toxic players, or which players are good teammates. Trying to understand what the most satisfying elements of gameplay are and what the least satisfying elements of gameplay are. We could figure out what parts of the environment they hate and figure out how helpful the tutorial is. Right? The goal here is for us is we start trying to better understand the components that contribute to the players' reactions to games. So we become better game designers because we can better understand how players are experiencing our games, and we can learn a lot more about why players feel as they do and how we can apply this knowledge to everything that we create going forward. I guess I have a lot to get through, so sorry guys, I know I'm talking quick, but I'll try and cover everything if I can. We can also do this over time. Like as game designers, it'd be great to know how somebody was feeling on their first game session and how that compared to how they were feeling on their 10th or their 100th. Right now we can kind of estimate it. Maybe you can do surveys, but it would be wonderful to know how people's feelings about our games, change over time and why. And then again, it's a convergence signal. We get to kind of combine this with everything we're doing originally, with our current playtesting, and in theory, hopefully become smarter game designers. So that was playtesting. The other reason, and this is actually what I'm most excited about, is adaptive gameplay. This is the second major way that BCI-based approaches could improve things for us. So here's an example from Left 4 Dead from long ago. Left 4 Dead is a zombie movie, and what we had in there was a set of techniques where we tried to estimate the intensity of the player, the survivor here, and create kind of peaks and valleys. And we did that by populating the environment with zombies. And hoping trying to create this, kind of like pattern of excitement, and then relaxation, excitement, relaxation, and so forth. What if we could actually do this based on somebody's actual physiological arousal? How would that change the experience? To us, I know it's a very interesting question. What if we could know if somebody was feeling positively or negatively? Just that. That's all we could tell was, yeah, this was a positive experience or a negative experience. We could start placing reactions in context. Game design would change, because you would understand, yeah, this was a good thing for the player and this was a bad thing for the player. And so like right now, we don't have this data, right? We infer it, and ideally if people play your games more, they're feeling positive about the game, but we don't know why. And so we can start trying to figure out why people are feeling good or bad about the things that are happening. And we start trying to, mitigate the impact of negative occurrences that happen and heighten the impact of positive ones. We could have adaptive enemies. So we could figure out what kinds of enemies you like playing against, what kinds of enemies are challenges, what kinds are boring. If we knew the answers to these questions, we'd have the game be more challenging and less of the boring kind. Difficulty levels can become a thing of the past. We could always adapt in real time to your skill level and how you were feeling. So if maybe one day you wanted a challenge, we could give you a challenge. If another day we wanted, you were feeling kind of like relaxed, we could give that, give you relaxation. If that feeling changed during the gameplay session, we could modify in real time. What's it like to only be able to kill an enemy while you're relaxed? Maybe you're a sniper, you need to calm down to fire. Is that a gimmick? Is it cool? I don't know. Maybe it's something different. as I walk through these examples, I know there are lots of kind of changes I'm discussing that won't necessarily work with conventional game designs, and that's fine. But I guess the interesting stuff for us here is that we get to think about new kinds of gameplay experiences that might be better suited to taking physiological data, and we could kind of shift away from some of the traditional paradigms that exist. The desire to work on things that are novel or new, right, is as a designer is incredibly appealing, and so BCI-based approaches, seem to be offering us that. What about having adaptive teammates? What kinds of people do you like playing with? What kinds of people do you hate playing with? What parts of the game do you enjoy doing? We could pair you up with people who enjoy doing other parts of the game. So you're doing task A and they like doing B and C, and then you have more cohesive teams. Again, we could identify toxic players and automatically mute them or separate folks. How would your gameplay change if you knew how your teammates were feeling? What if they knew how you were feeling? Like if your teammate was feeling scared or surprised or happy, how would that change how you actually played the game? I'm asking questions like this, not necessarily because I have the answers, because I think it's always going to be good, just because BCI technology makes them seem like interesting questions to ask. And so that is kind of like, it's one reason why I love doing this work, is because these are interesting questions. And I hope to at least, work towards uncovering some of the answers. What about having adaptive rewards? Start figuring out what you like and figuring out what you don't. And start tailoring rewards to the individual player. So we can avoid the things you don't like and provide more of the things you do. Like the underlying theme here is that I want to I guess the point I want to hammer home is that games in some sense are becoming less static. They're learning more and more about you and responding individually to what you're doing and how you're experiencing it. What about having avatars that mimic your mood and having in-game characters that react to it? Do you have conversations and interactions that more closely mimic reality? Right. So we're not going to solve a Turing test right now, but we are going to change how you interact with other people and other characters in games. Maybe that's really impressive. Maybe that's cool. I don't know. The point here is that we're creating feedback loops where you have a player intent, which is conveyed through whether the gamepad, keyboard, whatever, and also some of the aspect of their experience, input to a system responds, produces an output to the player, and the cycle repeats itself. But what happens when the game starts giving you insight into what you're doing and how you're learning, how you're feeling? How does that change things? As an example, could we teach you how to focus more effectively? Maybe become a better player. Meditation programs already do this in some respects. What else can we do? Here's a screenshot of one of our games at Dota. Don't worry if you're not familiar with it. The point here is that there's a lot going on that we could be adapting to the player's experience in real time. Which aspects of this interface do you like or dislike? Which characters or heroes do you like or dislike? How do you feel about the trees, the flames, the health bars, the combat? All of a sudden, we start becoming able to assess how you're responding to various elements in game, and maybe we can start having the game change things. We can make all kinds of changes just based on what you're going through, what you're experiencing. So how does gameplay change when you know what the player is feeling? When you have access to a player's frustration or engagement or challenge or immersion, or if they're in flow. We can give you cues when you're frustrated or challenge when you're bored. We could figure out when you're immersed and maybe start to understand why, or we could figure out what keeps you intrinsically motivated and better understand where we're failing in that regard. And we can figure out where extrinsic motivation, so external rewards, are unnecessary or where they really matter. We can figure out what leads to a flow state and when you're in it. We can improve accessibility, right, and figure out when players needed assistance and respond accordingly. One last example I have, this is a picture of a game we made called Alien Swarm. It's a top-down shooter. And just an example of kind of a new kind of gameplay experience. What we did was we gave people 4 minutes to kill 100 monsters. And we tied the timer, the 4-minute timer, to your actual physiological arousal. So if you got more aroused, the timer would tick down quicker, which would actually make you more aroused, and the timer would keep ticking down, so you get a negative feedback loop, which is maybe not a great game design, but it definitely was a qualitatively different kind of experience. So definitely a gimmick, and maybe not something we would ever ship to customers, but it did change how you're experiencing the game, right? And it added, it wasn't just your skill at maneuvering around the environment and killing monsters, it was also how calm can you keep yourself while you're doing so. So it was a novel kind of gameplay experience. So imagine a game where you actually have to be a spy and fool people using your words or your behavior or your thoughts, or a true role-playing game where you're playing a character. Things like this become possible when you incorporate, in theory, devices that are measuring physiological data, that are, kind of interpreting internal experience and providing those inputs to gameplay. Could we teach players how to play our games more effectively? Figure out when somebody's learning a thing and why they learn, and can we make them learn quicker? And then, conversely, and maybe more importantly, can we teach games how to play our players more effectively? right? So games become less static in this axis and kind of, they're more dynamically adapting to what a player is going through, right? So gameplay is becoming adaptive and personalized. We can modify the difficulty, gameplay, teammates, the weapons you get, the visuals, the sounds, the interfaces, the characters. Like the point here is that gameplay is no longer one size fits all. It's tailored to the player, and it's no longer a game for everybody, right? It's a game just for you. So sorry for listening through all that. I know that was a lot. Just really quick summary of why you find BCIs interesting. It's the first four, we get moment-to-moment insight into experience. We get objective data. We get to do it at scale. We get all this new kind of data that is amazing. And then really, even the more exciting part is all that becomes possible with adaptive gameplay. It really should be its own slide. But for us anyway, we are very curious about what kinds of gameplay can we create when we're adding in this additional axis of information about the player's internal state. We think the possibility space is incredibly broad, and so in the future, I very much hope this is how we play. Thank you very much.
Awesome, thank you very much, Mike. That was an amazing talk. A lot of content. That was great. Fast-paced. Some of the in the audience mentioned that a little bit.
Yeah. Sorry about that, guys.
But I understand that you had a lot of content to go through. So I think that we'll have to re-invite you to go more in depth in some of the aspects. We've had a lot of questions all over the place. Before we go to the next one, I'm going to ask a few questions that were kind of directed to you. Then we'll switch to the second speakers, and then we'll have the full Q&A at the end. But just because the amount of passion and interest with your talk, Mike, I'd like to just go quickly. But before, I saw a lot of people also sharing things on Twitter with the hashtag Neurotech Gaming 2020. So as I said at the beginning, please continue sharing information, even if it's a bit of shameless promotion, products, research, labs. If people can then just go on the hashtag Neurotech Gaming 2020, it will be a valuable resource to navigate through all this stuff. So please share anything you want to share that is relevant with that hashtag. And I want to also thank some people in the YouTube chat, like Brendan Allison, providing some resources, references to some of the different concepts that you mentioned. So thanks guys for making this a community. So one of the questions that we had on a more personal level a little bit, which we take very importantly at Neurotech X, is how did you get from studying psychology to game design? Did you study programming by your own, or what kind of extra course? So a bit of your journey of when you started to now being in the field at Valve from Santiago on Zoom.
Oh, sure. So yeah, my undergrad degree was computer science and psychology, and then I got a PhD in psychology. And in grad school, I studied visual cognition, so how people process visual information. And then when I was finishing up grad school, I was just trying to figure out, what I wanted to do. I didn't think I wanted to stay in academia. Like I love academia, but I was more interested in industry. So I was like, okay, let me apply to consulting companies, tech companies, whatever. But when I sat down and thought about it, I was like, man, it'd be awesome if I could be a consultant to video game companies applying psychology to game design. Like I didn't at the time, there were people, but I didn't know anyone else who was doing it. I thought there could be a need for it. I thought I could be good at it. I thought it'd be fun. So I'm like, all right, let me see if I can give this a shot. So I ended up meeting with someone from Valve at a gaming conference. They're like, all right, why don't you come out to Valve and consult for a day? So I came to Valve and put together a presentation on like 9 ways I thought psychology could be applied to game design, knowing nothing about the actual craft of game design at the time. And came to Valve, gave the presentation to a few different game teams, went to lunch with some of the folks there. And at the end of the day, I was just sitting in the conference room, and the guy I had spoken with came up and was like, hey, would you want to do this full time? So I got very lucky that Valve was open-minded to the idea of hiring a psychologist. And so yeah, so it's been there ever since.
Nice. So luck sometimes. Just show up, be there, meet people, and then you never know which opportunity you'll land on.
Yep.
Obviously, we had a lot of many questions on the projects, things like that. So I don't know what kind of juicy information can be shared with the audience. I'll let be the judge of that. But some of the people were asking, is there any partnerships or companies that you are working with? So obviously, feel free to.
I mean, yes. So there's a lot of people doing a lot of interesting work in this space. We have only so much time in the day to do things we want to do, and so the more people working on this, the better. So we are actually we do talk with lots of folks in this space doing interesting things, but I can't share any of them at the moment. So the general answer is yes, but the specifics will have to remain, I guess, quiet for now.
Okay, awesome. So we do have many more questions, but we want to make sure that all the speakers get enough time. So the second speaker, I might butcher the name, but Maciej Rudzinski, don't know if I was close enough, who is the CEO of Brain Attach, who's developing a biotactical gameware, brain-computer interface for professional players. So I'm very curious to know more about this biotactical gameware. So the mic is yours if you want to share your screen and take it away.
Okay, one moment. Can you see everything?
Yes, go ahead.
Okay, so like Roy said, I'm Maciej Rudzinski, CEO of Brain Attach. I've spent the last 12 years working on EEGs and signal processing. We are building, please move. Okay, so we are building an EEG headset for esport players, but we've heard what Mike said some time ago, and we were so inspired by his talking that we wanted to test if we can answer some of his questions with our device. So I will speak today about that. And to do that, we'll need a little bit of theory. Theory about emotions is really complicated, and I will speak only about one piece of it, about BCI reaction, in which I specialize. Then I will speak about our experience with playtesting and what we have found using our indicators in playtesting. And then what we have found using these indicators in our small test game, the few small test games that we've built for that purpose. And at the end, what consequences of that are in the future for this kind of devices. So this is our really one of three very small and easy games that we've tested on. Here we can see green player, and on the bottom of the screen, BCI reaction and arousal of the player. Monsters are popping up based on his state. So the BCI, this is a very old psychological theory about behavioral approach system and behavioral inhibition system. And to make it easier, it's your reaction about when you approach something or avoid. It's very, very simple, and it has 40 years of theory behind it, 30 years of experiments with EEG on humans. And it's based on recording signals from media prefrontal cortex. This is on your forehead, so we need only 2 electrodes and don't need to get to your hair, which make it quite easy to record. What we have done, what's the difference? What we have done with this indicator? Usually studies about emotions are made on quite large groups of 20, 30 people, and they work only sometimes. But the only thing that we've done, we've put quite a lot of statistics without any machine learning to make this reaction as precise as we can and to obtain precision of about a few hundred milliseconds so that we could combine emotional reactions with eye tracking, because we thought that would be the easiest way to work with games. Okay, so something have moved. I'm sorry. So to make it easier, just think about fish. This reaction of BCI is so primitive that you need to think like an animal. When you're an animal, you want to eat or explore, or something wants to eat you, or you are surprised, you don't know what's happening, so probably something wants to eat you and you should escape. This is the most basic emotion, but it's very good for fast-paced games, because when you are playing FPS, you are behaving much more like an animal because you need to react in hundreds of milliseconds and you don't have time to think about your actions for a prolonged time. One important thing, this BCI, this is not a reaction of positive, negative. It's sometimes similar, but to understand results that I will show, you need to think about it more like approach, I'm interested, or I'm surprised and I want to escape. We've started our test with Polish developer 12Tribe. They've built a game Neuroshima, and they gave us access to logs from inside of the game. So we've had our EEG, logs from the game, and we've asked many questions to participants of this study. That was a few years ago, so I'm sorry for the quality. But like you can see on the left, we have reaction of the person and all the logs that we have collected from the action. On the bottom screen, we have flow in the game, and person is completely lost. Why? Because in this game, when we started playtesting, they've thrown monsters from the beginning on the person, and people were just didn't know what's happening, so they get into the surprise action. I don't understand. I will get back to one more thing. We've tried to attack this. We had so many data. We had information about the reaction of people from every part of the second. We have all the logs, but we could not find any stable pattern in the game. Why? We found that we can, but we just need to separate kinds of the data. People react completely differently to every sense. So when we hear that somebody is shooting to us, we react in 100 or 200 milliseconds. When we see something and want to move based on that, we need 300 to 500 milliseconds. When we are reading and trying to understand the situation, it will be longer. And when somebody says a joke, it will take a second or more, or we'll never see the action. So the person didn't understand what we are saying. Because of that, it's really hard to work on simple logs. You need much more work and much higher statistical devices to work with data. But we found something else, and it's not even we found that. Our game developers said to us that when we combine reactions from larger parts of the game, the pattern that you can see on the bottom of the screen looks like flow, and that they can discern from that when people were completely immersed in the game, which parts of the game were more important for them and better built. Here you can see me playing Gwent from CD Projekt Red. Really nice game. Like you see, you can see now that I've lost, but in this game, it's sometimes very good to lose, and that was one of the high moments. But it was not the best. This is important because when you usually ask people about the games, they mainly speak about content which is easy to speak about, and that would be when you are fighting with someone. But when you look at here, you can see that for me, the most important action in the game was building a deck. And these were quite, nothing happened here. I've been just thinking, but for me, this is the largest pressure. I'm a nerd which likes counting, and I'm a munchkin. So you can see here that that was the most important moment with highest amount of emotions, largest dynamics, and a few more things. Okay, but what the nice thing that we found that you can use in the game is the concept of thin red line. So in most situations, we are measuring our arousal. And there are many methods for that. But with arousal, you're aroused in situations where you are winning, and you're aroused in situations when you're losing. And when you measure emotion like BSBAS, you can discern the moment when person is is playing good, he's winning and able to kill any monster that comes to him. But when this extra, that we have one monster too much, and his attention is unable to grasp the situation any longer, and he have no escape, we can see that he have crossed the thin red line and lost control of the situation. And this you can find only having very precise method for measuring reaction that have two sides, the good one and the bad one. Next thing was a flow. Like I've said, we didn't even know that you can find flow in a BizBus, but in a same measuring. So I believe in them. The thing that we found that's extra thing that we found is it's not only that you need difficulty of the game comparable with your abilities in the game. You also need pacing. So your brain is unable to constantly be in attentive state. You cannot pay attention to everything for a few minutes. You have your own windows. And if game is constructed in a way that your timing of your brain is the same as the game's one, you are getting into the flow. If, of course, difficulty and abilities are similar. And this is very nice to use. We think, but we didn't test that people choose types of games like RTS or FPS based on their internal clock. So people which have larger attention spans play RTS. People which have short attention spans but recover more quickly play FPS. Okay, with all of that knowledge, what new things we can build in games? This is a simplified version of how you can build easily a game based on measuring somebody's BizBus and arousal. Let's say that this sinusoid, which we have down here, is your BizBus. And it's sinusoid because, like I've said, we cannot constantly be on one level. We cannot have constant emotion of one type. We need, our brain are constantly changing and they need their pause. So if you want to build a game that's perfectly matched to a person, you need to throw monsters on that person when they are ending their pause. So you know that in a moment they will have enough strength to fight once more. But we want to adaptive difficulty. And this is easy because you're putting monsters on in the game as long as person doesn't get with his or her arousal to high enough level that we think that he is approaching at this thin red line when he will lose control of the game. So in this way, with quite easy code that we are happy to provide and with our test games because we want to open source them, you can easily take adaptive difficulty and pacing of the game in one shot. And if you are adding to that, the fact that you are measuring how person is feeling at the end of the wave of the monsters, you can easily build a personalization method that shows to people mostly these monsters that currently they have more feeling for. Okay, but there are many other aspects. I won't speak about most of them because Mike gets a really good job and showed us much more things that I could. We are just scratching the surface in our company, trying to testing impact of putting emotion on avatar. But I don't mean that your avatar is changing his face, but that other players can see in what state you are. The fun consequence of that is that people are starting to synchronize. When you have a group of people playing and they can, for example, hear their own emotions and emotions of other players, you can see that they are synchronizing and playing more unisono. But we need to, if we want to use systems like this in building games, we need to remember that after using devices like that, we are getting people into a constant biofeedback. And we know that people play games for prolonged time. We have no idea what will be the effect on people's brains when we biofeedback them for many hours, for every day, but we are sure that the impact will be great. And this impact is based on what we are measuring. If we are not measuring correctly the things that we use in the game, we can put people in a harm. But if we are doing that right, maybe the next set of people that will play these games will be much healthier. They will be able to control their arousal and attention thanks to mechanisms like that. So we need to design games with user health in mind. Okay, but why did we build our device if our technology was working for many years? We found that we can track BSBus only on high-end medical devices. And we could not find any other device that had good enough quality for us to measure emotions. So we've built our own device tailored for our approach and our algorithms for noise cancelling, because this is one of the largest parts which we had to take care of. And every choice in our device is made based on how our algorithm is working. So every filter, every choice of the shape of the headband and any other. Okay, but we are a startup. We are just starting. We've produced our first devices. We are searching for people that would like to work with us on creating games based on BCI devices. And for people which would like to sign up for our on our website, we have a nice discount for that. Thank you.
Thank you very much for your talk. That was very interesting. I hope that you guys can all hear me okay. I changed my mic. I had some feedback. I thought my mic was plugged in, but apparently it was not. So we're receiving a lot of questions. And as I said, we'll go through, well, not most of them, but some of them at the end of the Q&A. Thank you very much for all the engagement through this event. We do have another event tomorrow as well. So if you wanted more at the end of today, definitely show up tomorrow at the same time. So some of the questions we had that I want to go through quickly with you. People were asking a couple of questions, obviously, about the device. I think that this last slide answered that in terms of, is it any way to beta test the technology, the timeline, where they could get access to it? And if you are working with academics as well.
With great pleasure. We are currently in a mode of developer devices only. So we'll have our device for population at the end of the year probably, but at the moment we have only devices for developers. I think that this answers the question, and we are very happy to work with people.
Awesome. So the best way is to go on the website, subscribe if people want to do research. Awesome.
And the more people subscribe, the faster the device will be on the market.
Awesome. In terms of the emotion, we have a question from Christopher on Zoom. Have you combined your neural data with eye tracking in order to get a more specific understanding of what the player is reacting to?
Absolutely. Yes. Yeah, you can hear, you can, one moment, sorry. You can see on the, okay. This dot flying on the screen, that this is an eye tracker. So yeah, we've combined eye tracking with EEG. It works quite nice.
Perfect. Sorry if I missed that. We're overwhelmed with questions. So in terms of another question, how do you ensure accuracy of the device and it can be paired with VR?
How,
two questions.
So first, how we assure the accuracy? For starters, we compare it with a medical device. Second thing, our largest concern is signal quality and signal cleaning. So really, nearly everything that we've done is to create signal cleaning algorithms on many levels. Up to the level that we have had to change how we show data to the people, because the last part of the signal cleaning is showing it in a way that people can understand that. Because we have much more data that you can show, that you can see here in this video, but we don't show them to people because they are unable to process them. This data are only for computers. And with VR, we are trying. And we would really love to combine it with VR, but we didn't try.
Excellent. So we do have more questions for after, but I would like to invite our third speaker. So we have Dmitry Mikhalchuk, co-founder at Tesla Suit. So they developed a full body haptic feedback suit. So I'm definitely excited to hear more about that suit. So Dimitri, you can share your screen and take it away.
Yeah, thank you very much. Hello, everyone. I will quickly tell you about the suit. Launch it. Yeah, so for those who don't know, the Tesla suit is the, we call it a two-way communication tool between human body and a digital environment. And so today I will be speaking about the effects of neurostimulation on learning and training. And this is a slightly different angle to the BCI approach and measurements. And this is where we could provide as well some additional data for the BCI to kind of collaborate on as well with BCI companies. Currently, we're not available as a consumer product yet. We're looking at ourselves as a professional product. So we're working with research centers, enterprise, high-end esports, and general training within the enterprise itself. So just to recap, the Tesla suit itself comes as a two-piece solution. It's a jacket and trousers, and it has haptical feedback, and we provide it generated through the EMS and TENS. So the two technologies are electromuscular stimulation and transcutaneous neural stimulation. We have heat control as an option as well. We have 10-point motion capture. On the body, it tracks the entire skeletal position using IMU sensors, and we have a fusion algorithm where we can pair up with optical tracking, being it either lighthouse or OptiTrack type or camera type tracking. And we have a biometrical feedback. Currently, we're measuring ECG, EMG, and myography sensors. So together we're, and galvanic scene response, sorry, GSR. So these systems in combination help us to essentially build both the collision and the stimulation system where we can have a full kind of two-way communication between the body. And this, an interesting example where an adaptive technology, an adaptive scenario could be built. Essentially, when we're going in full VR, for instance, the world needs to know where the body is and how the person is actually, what psychological state the person is in. So some of the cases to help you understand how the Tesla suit affects the person. For example, the haptics. One of the launches that we had with Vodafone 5G in UK was a simulation of a tackle across the 100-mile range, and we used 5G for that, for transmitting the sensations. And just to explain the schematics on there was that we had real cylinder, tackling cylinder, which was placed on a Ricoh stadium in Coventry, and we had real people tackling it. It had accelerometer built in, and then it was connected through the computer to the 5G network. And in London, we had a person wearing the full Tesla suit on stage, and essentially he was going through the exercise of being tackled. And we demonstrated how an interesting factor. So we've sent a couple of kids through to tackle the cylinder so he could feel it a little bit. And we didn't tell him that the last person that will be going is the biggest, probably 7 foot tall, biggest player of his own team. And then the tackle itself, and we have some YouTube videos online. Unfortunately, couldn't cram it into this presentation, but this is where the tackle itself moves the person. So first part is the physical contact and the ability to actually affect the body to the point where we feel that the world is interacting with us, that there is not just sensations of touch and various locomotion, but also strong kind of heavy impact and things like that. So we could generate that. Another activation that is interesting to look at is what we call feel the drive, and we've done this activation with Formula One. This is where we were provided kindly with the telemetry data from the Formula One, and we had 7 different parameters: so acceleration, deceleration, DRS data of the car, and distribution of G-forces. And this is where we converted the G-forces, various G-forces that exist when the Formula One car accelerates and decelerates. And we essentially created the physical sensations of what the muscular system would go through once the driver is going through the corner, for example, at 100 miles an hour. What was interesting, we were giving the visual, the 360 camera view of Lewis Hamilton. He was driving the car at the time, so we replicated exactly what he felt whilst driving his final lap. And then we had VIP visitors of the paddock at Formula One trying that, wearing the suit, and essentially one of the guys who was a test driver, pilot test driver for the Formula One, he said that that was the closest to the real experience of how the body is affected. So essentially, from those points, and we saw how public was mimicking, even though the steering wheel and the seat were not moving at all, the steering wheel had no physical feedback. We saw how people reacted and basically mimicked whatever the actions were going on the screen, on the AR headset that you can see on the screen. So we thought, if the visual stimulation is enough for people to trigger that response, can we actually influence the type of behavior? Can we start working? And this question was coming quite often from esports teams as to how can we use the technology to start essentially practicing more and understanding how to train the reaction and how to improve the gaming itself. So what we did next is we tried what's called subthreshold stimulation. So on the picture you can see where we've essentially before and after applying the haptical stimulation, essentially the middle pattern on the brain hasn't changed. So we didn't affect the visual understanding of what is going on, but on a subconscious level, the stimulation was barely noticeable. So in fact, it was unnoticeable at points where the person had to react. And an interesting effect that we've observed on people trying the laps over and over again. And so on the next slide, I've got, so we had an error rate drop. Essentially, time after time, you can see that the first lap, there was a lot of errors. It's circled in green on the left. And then every next lap, consciously people were making less and less mistakes compared to, so every attempt itself, they were making less mistakes on when to start the reaction, when to start the turn, for example, because for instance, on Formula One, the movement is so fast, but that the eye assessment is not fast enough. Essentially, the delay, the brain processing is so slow. It's not fast enough, essentially, that one needs to go by literally by the senses. So training those senses to react in advance is what we were observing and trying to build up. And so what we then tried is we've added haptics as well. So that was the subconscious stimulation. And then we've added haptics. And on the next slide, we have the reaction. So rate of successful actions when we added haptics was first it dropped because the body wasn't conditioned well enough to have also the full physical feedback to the visual. But then we can see that the reaction, the successful action rate has gradually started growing up and up and up. So that shows, and this is just a beginning of our essential neurostimulation study that we're conducting, and we're inviting the research centers and enthusiasts to join us in this journey to essentially build up a system where we can provide a training facility, a training solution essentially, and also by joining with BCI and eye tracking, we can have also an interesting testing environment for the content itself. So this is where if the adaptive content is needed to be designed, then the question will always be, how do we test it? And so we need to collect as much data as possible, obviously. And in terms of when we're in VR, it becomes even more complicated because many factors are kicking in. So when the person is immersed, so it would be very interesting to collaborate on this and explore the new ways. But I'm so excited that actually the sub-threshold, and this has been a big argument for quite a while, whether sub-threshold stimulation would work, essentially because it's so close to the threshold, to the actually noticeable stimulation, that previously was very hard to separate the two and to prove that the one is not affecting the other. So currently, we have found a good progress, and we're working on actually publishing this study and demonstrate how, with the Tesla suit, we can influence essentially the user activity and how well the user adapts to the environment and how they can process the environment and decision making and the entire cognitive preparation within any synthetic environment that is pre-generated, and they haven't seen it for the first or seeing it for the first time. So problem solving definitely improves, and so this is what we're trying to add to the game. So ability to go through all those studies as well. So this is pretty much my presentation for today. So if you have any questions, just fire up and let's discuss.
Awesome. Thank you very much for this great talk. A lot of people were excited about the suit. We had some comment asking, why don't you do a consumer version? Because I love your product. So some people seems to be using it on a B2B model, but asking for a consumer version.
Yeah, so we essentially, when we started designing it, we always saw it as a consumer version. So we wanted to build a consumer version, and we still want to. The only reason for that is there are no specialty chips, microchips, for example, that would solve the specific technical parts, technical issues that we're covering at the moment. So electronics is too complex overall, and so that impacts the final price. So, but as with the VR itself, at the last wave, when it kicked off, the VR companies were using mobile phone or tablet chips in order to generate the graphics and to process the Wi-Fi and everything else. So, and after that, the big players started building the specific, very specific chips for the headsets, and the prices have started going down, which is a nice thing. We've also kicked off a project. Unfortunately, we can't speed anything up because we have to deal with massive corporations, and for them, we're too small overall, and the market is too small. So it's progressing, but we're building a system on chip that will allow us to receive one single SoC, which will solve most of the issues. And after that, we should be able to lower the price quite considerably, as the complexity of the overall system will reduce, and yeah, we'll definitely come to the consumer market. We're working on this. Just bear with us a little bit.
Awesome. In terms of so you talk about the tech a little bit. People are asking also in terms of the material. Is it comfortable? Can you elaborate a bit more on the fabric and the material of the suit, or definitely not?
Yeah,
this is not absolutely my area, but for some people in the audience.
Well, we're not hiding. I mean, we've visited probably over 150 different events. We won the Innovation Award at CES 2019 last year, and we won Best of the, I think, Best of the Peripheral Haptic Device this year at CES as well. So in terms of fabric, in terms of textile, I think we've gone through more than 50 iterations of different suits already, and we're trying to improve the textile itself. For us, and for example, the feedback that comes from the location-based entertainment companies is that the time to get in and get out is the biggest factor. The traffic is important, and so we're looking at essentially getting into the suit from the point where you have it on your desk, for example, to fully on and connected to the system, and you're ready to play. Within 3 minutes, you just put it on. It wears just like normal tracksuit. So you get trousers and a jacket which just zips up, and we have some velcros to tie it up in places so the dry electrode system touches the skin well, and that's it really. It's a very straightforward kind of process to put it on and take it off. So
do you know about the long-term and short-term adverse effects of the TENS and EMS?
Essentially, we're following the guidance of British National Health System, and in our case, with low-powered EMS and TENS, we advise not to exceed probably 2 hours of continuous use, and then just take a break and then come back. On top of that, we know that the neural effect on to the stimulation is that the neurons will become number anyway. So the senses will change with time. So it's always advisable to take a break a little bit and then come back to it. In the lab, I know that the guys have been using or wearing the suit continuously for 6 hours straight. Every time we test it for wearability, this is probably the average time that they do in the suit. But of course, we don't send them through like continuous stimulation process. But also in games, when we're looking at randomized gameplay, obviously the same point never gets stimulated like continuously for a very prolonged period of time. So gaming may give us a longer runtime as well. But I would definitely advise you to take a rest. When we really started seeing some injuries from people going for too long in VR and forgetting that they need to start moving, they need to exercise and take some rest, drink a little bit of water every now and then. We had some guys complaining after they've gamed for too long, because we were trying to test and push the limits as to how much can we use the VR and the mixed reality, and obviously our product with it. So yeah, the advice is always take a break.
Excellent. Just a last question before we go into more general Q&A, because some people mentioned it and I find it personally also interesting. F. Erith on Zoom commented that your suit remind her or him of a TED Talk on a suit creating new sense. So I think that she's probably referring to Neosensory. Have you looked into sensory substitution at all with that technology?
Well, we've been working with different research programs across the globe, and some of it involves, for example, replacing or retraining the sensory cognition in people who lost their limbs. This is a very complex study and a complex type of rehabilitation, but this is where we help the people who lost their limbs to essentially to retrain the brain, the neural cognition, where we take essentially we build a system in VR where they can see their entire body intact, but obviously they're using bionic arms, bionic parts, and the bionics have external sensors that actually allow to feel some level of pressure, for instance, and we're transmitting it to through the muscular system, through the neural system as well, directly to the brain. And so essentially a lot of studies being done on that, on trying to replace the senses, but it's not that easy. I mean, the body is very complex, and the actual sense, when we took it, when we decomposed what the haptic is, like true real haptic, and we saw that on top of the electrochemical reaction, for example, we do react really well to heat or speed of heat exchange, for example, and that's how we feel different textures. So anything from wooden surface to metal surface, even though they're all both ambient temperature, we feel that metal is colder, for instance, because of the speed of heat exchange. So those are technologies that are still very new, and it's very difficult to replicate it. So our skin resolution, sensory resolution is very high. So we sense a lot of things. And so to get the electronics to that small level, but also make it portable, wireless, run off battery, and still connect to VR, is a challenge, guys. I mean, we've been working hard, and we're actually progressing. So we've added heating. We're now working on like 8-channel. At the moment, we're like heating parts of the body. So to even give a cue that the source of heat is there. And so if you turn, you can feel it. You can sort of feel where it is. And so it's relative to your position. Work never stops, and we're trying to get to the smallest possible kind of point to see which is commercially reasonable to build. How small should they go, and how well defined the haptic is needed for general world application. The problem with that for us is that there isn't much software or games that we could pair up with that already support, for example, haptic. So we have to talk to games creators, to the integrators, to work with us, and at times we just asked to integrate our suit so we could even run the tests, run the simulation in this and that product. So those are the challenges of the new market, essentially.
Got it. Thank you very much for your talk. So while the team, so we do have a couple of people that you might have seen the names either on YouTube, on Zoom. So Slava, Brian, Sophie, Ilya, a few people behind the scene aggregating the questions. We've had over 150 something questions so far. So obviously we won't be able to go through all of them. That's great. For sure, what we're going to do is that we're going to group them. Make sure to subscribe to Neurotech X newsletter because we're going to follow up with some material based on the questions, if we can answer them, if we can aggregate, or might actually ask the speakers as well the questions, if we can package more information for you after the event to continue providing value. So for those who are new I'm just going to stop sharing your screen and switch quickly to my screen. For those who are new with Neurotech X, just a quick introduction about the organization. So we're an international community, and with the mission is to facilitate the advancement of neurotechnology. So that is obviously a very broad statement. In order to achieve our mission, we do have 3 pillars: community, education, and innovation. The idea is to bring people together, a little bit what we're doing here, connecting people. We do a lot of physical events as well. We do provide educational resources, and then innovation, we help support with professional development, job board services, and things like that, to then, once people are connected, educated, they can go on and have an impact on the field. So we do have several initiatives. I'm going to go quickly on this because we do have amazing questions. But in a nutshell, we do have chapters in 20 plus cities. We do have student clubs for undergrads. We do have a Neurotech X Slack that I would invite you to join, EDU platform, newsletter, and we also offer services for recruitment and consulting. So if you're in need of any services, you can contact us. So quick numbers, as I said, 20 chapters, many events, large community, and on our Slack platform, we currently have over 4,600 members. So if you want to continue the discussion, feel free to join us with the bit.ly link on Slack. If you're looking for an opportunity in the neurotech space, we do have a very active job board. So feel free to go there and look what you're looking for in terms of your next opportunity. And tomorrow, don't miss out on day 2. We're going to have the continuity of this event, another awesome hour and a half of content with Neurotech and gaming. And right after this event, and I would ask Brian, Sophie, or someone from the team to put the link on Zoom, and it will be available on our Slack as well. We do have a Neurobar. We did that with the BCI 101 series. Our last series of event was really successful. The idea is that you show up with a drink. Any drink can be a glass of water, and then you'll be redirected to different rooms according to your interest, and you can continue engaging and talking with people. So please feel free to join us. We cannot really share the on YouTube publicly because then it goes all over the place, and we have people disrupting these calls. So either on our Slack, on our Zoom right now, you'll get access to the link, or you can just reach out to any of the team member for more information. So with that, we're going to go back to the Q&A. So I'm going to stop sharing my screen for a sec. Here it is, and we should be back. And I would invite all the panelists, the speakers, to mute and unmute themselves as they go and as they want to answer. The question the team has tried to gather things that can be answered by everybody to bring as much value to the audience as possible. So first, let's go a bit more on the medical aspect of things. Are there any games for people with disabilities, particularly brain injuries? So we talk about entertainment, but obviously brain is related to the medical space. So can we just touch a little bit on that aspect of things?
I guess so. People are absolutely working on games to use in rehab and to use to kind of train folks who are suffering from cognitive or motor or physical impairments. So it's still a very active area of research. Obviously, at Valve, our focus at the moment is more on the entertainment side, but there's definitely lots of interesting work being done on kind of like the rehabilitation side. Games have a lot of potential in terms of their ability to be adaptive and kind of tailored and repetitive, and progress can be measured. So there are lots of fundamental aspects of games that are kind of would be useful for rehab protocols, and so folks are absolutely working on trying to I guess use them in the medical field for folks who have suffered brain injuries and other impairments. And my guess is a lot of those interesting research will come out of this space. Just because there's the benefit to humanity is so great, and kind of like the use case of bringing in game-like environments to rehabilitation seems to have so much potential. So.
Great. Then no more comments from two others, so we'll just continue with the second one in terms of the. Yeah, go ahead.
I can comment. I don't know about games which help with that, but we have seen with our device that we can quite easily see when people stop thinking, have problems with their attention, when they have good or bad day. So everything is there to create games that could help us to build our attention. But I don't think that we have enough research to be sure when they will be good enough.
I can add to this probably. We don't have, for example, games as a commercially available games released as such, but obviously working within the medical rehabilitation field, we have VR a set of exercises. They're not commercially available, but if you guys reach out, I may be able to speak to get those released, for example, and those will be for various devices. And you can probably explore what some of them are quite interactive because they're encouraging the exercise itself for those who have disabilities or stroke, or going through stroke rehabilitation or relearning the motor skills. So those are both games and not really games as in commercial games. So this is what I'm seeing in our labs day in, day out. This is the time.
So back to gaming for entertainment, what kind of games would you see that would work with different, with Neurotech actually? So more on the horror, fantasy, adventure, what kind of game or genre do you think that will be more affected, or the first one to be affected with Neurotech and BCI?
I mean, I guess the honest answer to that question is we're not sure yet. We need to figure out the kinds of signals we can reliably detect, and then kind of craft experiences, as a consequence of what we figure out. At the moment, everything is open, and I don't kind of see any barriers, I guess, to including this sort of information to kind of almost any kind of game. But this is the work that we have to do, right? We have to figure out, okay, here are the things we can get with an eye tracker or an EEG or a heart rate sensor or galvanic skin response or a webcam or any other piece of technology. And then as game designers, the onus is on us to come up with compelling gameplay that takes advantage of it. And so yeah, I like a priori, I don't see any reason why we exclude certain genres. But we honestly won't know kind of what game designs are best suited for what kinds of gameplay, what genres of gameplay are best suited until I guess we kind of build up our repository, our knowledge base of the kinds of signals we can reliably detect with commercially or consumer grade equipment.
Okay, from our experience, we found that we are able to measure very fast emotions, but the brain is working really really fast. And when it sends us signals, it doesn't care to show them in a way that's understandable for us. So the emotions that we can catch from EEG and other sensors are very basic ones. They are about the fast reactions. So they will probably work only with, at the start, of course, with very fast-paced games like FPS, maybe with some RTSSs. It will be much harder to use EEG and similar devices to games with higher concepts. If you want to think about strategy, you have so many ways of thinking about strategy that reading that information from the brain will be really, really hard. We can, at the moment, we can read only the simplest possible emotions, and at least from the things that we have seen, we see mostly emotions which are not audible. The emotion, not the emotions about which we speak. I love something, I hate, I had a strategy to build a city and something. No, we see very fast emotion that the thing that I've seen is not the thing that it's not a thing that I thought will be there. So this is a very fast reaction on completely different level than we usually think and create games in. So it will be much easier to use BCIs for fast games where we behave like animals, where this kind of emotions is easier to understand and use. And then slowly, I hope we will be able to build a next layer of concepts on that will help us to use that in RPGs or strategy games and things like that.
Dimitri, any comment on this one, or I just move to the next one?
From what I've seen, yes, FPSs work, I think, best at the moment. And we've used also the galvanic skin response, which also shows the level of stress that jumps up and down, and some of the emotions as well, and the level of focus. So that worked really well with scare games, like proper FPS. So, and didn't work too well with strategy, because yes, the overall game pace is different, and so it's difficult to gauge that yet at the moment.
So gaming is quite, oh, go ahead.
It's about the level of the concepts. The concepts that we use when we develop games are quite high end. They are quite high in the hierarchy. But the things that we can see easily in the brain are the things that work on the large surfaces. We can only hear very strong signals. So I guess that we will be unable for a prolonged future to see very precise ideas, strategies, and things like that. We are not there yet. I think that Mike spoke about that in a different presentation. If we record for long enough time people playing games, then we'll be able to collect that if they react to some amount of action in this way, and we have the spread of different kinds of emotion, we'll be able to build more complex concepts. But you need to record people for a really long time. So like Mike said, until we will have many devices of the market and people will play for many, many hours in many, many sessions, we will be unable to use BCI for anything that's more complex.
Got it. So many hours, but with breaks in between if you're being stimulated.
Right.
Gaming is quite addictive already. So while getting data and insights on a person's emotion be used to get on gamers more addicted. So how do you see this addiction thing coming in now that we're trying to loop into the brain to get it even more potent?
I have a story. When we started a year ago, we went to a hackathon with a very simple Python game, so that it will be easier for people to build the game. Game was the dumbest type of the game that I've ever seen. You had balls spreading from right side of the screen, and you were a pixel on the left side of the screen shooting at them. So nothing happens. This is as boring as it can get. But when we hook up a girl to test the game and the parameters, and we forgot about her for half hour because we were trying to do something with the code. I've been unable to take my device from her because we needed to go to the to show this effects of our work, because she was so hooked up to the game that she didn't want to give it up. So yes, they can be really, really addictive, even with the simplest possible mechanism. If you know clicker games, they have very simple rules, but they can hook very strongly. So it's very important how you build a game. And I think that, like with Dimitri's device, you need to put some dampeners on your technology that people will lose precision of the indicators after some time, so that they will not play for too long, because this could get really dangerous, possibly.
Yeah, absolutely. So I think it would be probably the developer's responsibility. I know we're trying to get people to play the game, to come back to it. The whole popularity of the title depends on that. But I think the scenario itself needs to be built in a way that essentially allows the brain to relax a little bit, so we get back to our conscious self, and then make sure we make a conscious decision then to take a break and then come back to it, because it's ever more enjoyable when you're taking it in portions, and then you let your brain rest a little bit, and the levels of dopamine drop a little bit, and then you feel the better jump, and that actually will affect yourself in a positive way better than if you're continuously spending time and time and time.
Yeah, I think Maciej and Dimitri covered it well. I mean, the onus is on us as game designers, right, to use this technology in ways that genuinely improve the experience for our customers in a way that increases their enjoyment, and not in a way that that could be negative, right? And so, I mean, the same ethos that applies to the games we design now. We want to make games that are enjoyable to players. We want to do it in a way that it is genuine and meaningful, and not a trick, right? And not relying on some way that could lead to kind of negative outcomes for players. And so, like, that same ethos that we use for games now would apply to anything we made with this technology in the future. And if we couldn't do that, then we wouldn't use the technology.
So the question is broader than just the tech itself. It's more about the game design on its own, the addiction. The tech won't enable necessarily. It's the same paradigm being translated with now more tech.
Yeah. We went to games because this is the place where when you make a product which is really nice for people, you're not harming them. There is a way to make people more happy. And the thing that's best from my perspective is the fact that when you measure people for prolonged time, you can measure not only how they feel exactly in that moment and work to boost their happiness in this second. When you have many sessions, then you can shoot for making them happy long term. And when you do that long term, then you will make sessions shorter, because you will know how short you can make them so that they will come back to your game. You don't need to addict them so they will spend 8 hours a day.
Interesting. We do have some more questions. So I want to be respectful of the time. I know that we're at the end time right now. I want to ask you if you'd be comfortable of staying 5, max 10 more minutes just to go through a few more questions, but feel free if you need to drop off. I totally understand. But since we had so many questions, I'll try to pick the good one what my team did, not me. So can I pick your brain for another 5-10 minutes?
Yeah.
Awesome.
Sure.
Thank you very much, and thanks for the audience who's staying with us since the beginning. Privacy seems to be something more and more concerning, obviously. So what are the best practices in your company considering for data protection, EEG, and other biometric data, which is more than just behavioral now? So we're entering in a new era. Do you want to just comment? Maybe it's a bit too early, but just what are the best practices and how do you see the future in that space?
Yeah, the moral question was one of the first ones that we actually put in front of ourselves, and we were initially, our design entirely is based on security of personal data. The sensors that we went into, they allow to identify the specifics of a specific person. It's as probably good as having IP addresses and probably make a model of the specific computer, and we can identify that the user is that same user, for instance. On a ECG, on a cardiogram, we can see the rate of the heartbeat, but on top of the rate, we can see for example, the valve differences in the heart between different people. So if we can read that, that's a very specific data that shows us too much, I think, about health. So currently, because the device is intended for medical use and research, we do nothing with it. We currently outstream the raw data. We did take care of the channel itself, so we make sure that Tesla Suite, for example, will simply not connect, not talk unless the key matches. So our encryption is like AES-256 with a 2048-bit key, similar to military encryption. I know it's penalizing on traffic a little bit on the CPU itself, but security is our priority. So we don't want anybody to steal any data or be man-in-the-middle kind of attack. But when we're looking at consumer level, and that's why we have to go through every single angle, you know, we need to understand what can be gained in terms of an attack. So we most likely will scramble the data. So we'll tokenize most of the stuff, and we'll have to put some kind of limits, even giving it to developers. We need to understand how it's going to be used and abused. So and actually set the protection. And initially, what we did, we even designed a PCB in order to stop the haptics. For instance, if the haptics goes above some high threshold, we don't want it to last long. So we don't want any developer to forget a function that will go into an infinite loop, and then suddenly somebody is incapacitated, can't get out of the game. we had a few incidents internally when the guys forgot to sort of recompile the code after we tested the error itself. So, but they could at least call for help, you know, if somebody was always next to them. So all these things we need to study, we need to carefully assess it, and obviously when releasing to the public, to the consumer, the product has to be spotless, and that's what we're actually working towards.
Okay. So there are many levels on which we can ensure that the data are protected. We have, for example, the attached, the obtaining of the data, processing of them, and giving them to other companies that use them in their game, so that no company knows what other part of the system knows. We destroy the place where data are processed. It doesn't get the keys that allow to know which person is that, for example. So from the start, the keys that could allow to understand the people are destroyed. But we still, the information that we give, if you are a man in the middle and you can never protect completely from that, somebody can listen and see your signal. So we are only sending these parts and these versions of the signal and data that are needed for this particular purpose. So we are discarding and destroying most of the information. If people don't need all the information that there are in a signal, and there are many more than for the particular use. So we destroy all of that. One of the important things is that this bus about which I spoke, it was when people started, it was used to find personalities. It was not used to see how people react to objects. It was used for personality. So if you have even a 10-minute recording of a person, you are starting to, if you don't discard and destroy this information, you have some information about their personality and preferences. And we've checked that you can see preference. If you have enough data of particular kind, you can see people preferences. So this is very, very important how you store and process data.
Yeah, I don't really have much to add other than like the same practices we use, I guess, with current data we collect, we'd apply, right, to the data we collect from any device that was gathering stuff. Like the goal, the reason we have data is simply to improve the experience for our customers, and that's it. And so if it wasn't doing that, we wouldn't keep it. And with GDPR and other such regulations, like it's very easy to kind of see the data that's being collected and what it's used for. And so it's nothing again changes about the data we collect via BCI-based devices versus what is being collected currently. Or nothing about our practices changed, right? Like we collect it and use it to improve the experience for our customers. And if something is kind of running counter to that, then we wouldn't collect it.
I do agree. We could dive deeper into the privacy and privacy policy, obviously, of the company and these devices, but not for today, for another day. We talked about using it as a device to improve the experience in the game. What about, and Praveen is asking, can BCI be used as a training biofeedback mechanism for professional esports player? So Maciej talked a bit more in that space as well, but can these devices be helping them stay in the optimal performance zone?
Yes, because when you are on the level of esport players, on this level, they all have similar, they move similarly, they are as fast as other people, and the thing that changes which team wins is usually psychology, how they feel. So you have two phases. One phase is before the game. Am I in a good mood or bad mood today? What actions should I take to feel better? That's one thing. Second thing is while you are playing, to check what's putting you out of the balance. Flow is very choosy. It can be destroyed by very teeny things, by comments from your friend, by mouse moving incorrectly. You are on the flow only if nothing disturbs you. And there's a okay, so you can train for obtaining flow and not taking care of things that you don't like. But we think that the most important job that people can do is to train while listening to other people's emotions, so that they can synchronize as a team, so that they can know that somebody is not losing because he is stupid or something, but he's not in his moment. When shall I help somebody, and when it helps? So you have like three phases when you can improve somebody's work, and two of them can work even outside of esport in other kinds of sports, for example.
Any more comment or feedback on the biofeedback flow for esports players?
Yeah, well, it sounds very interesting. I mean, the emotional part is, I think, is important. Probably not talking about BCI itself, but talking about transcutaneous neural stimulation. It is quite capable of keeping and improving the neural elasticity. This is where the brain will continue to be open to learning, and the skills, the reactions that we acquire is a process of learning. So with time, our brain loses that elasticity, and so sometimes we need to change the type of exercises to keep that going. We see that a lot in fighter jet pilot training, for example. They have to have a very high level of neural elasticity to be able to mitigate the cognitive overload that they go through at very high velocity maneuvers. And so, yeah, in terms of electrical stimulation can help with that. I don't think there is a ready-made off-shelf kind of solution that would work straight away, but it is possible to design one, I think. It will be very individual.
And at Valve, since you obviously in the esports, we think about Dota 2 being one of obviously the money pool being the biggest. So I guess that you have a word or two to say about that.
Yeah, I mean, I think so. Getting into flow state is incredibly interesting to us. Understanding how people learn things is incredibly interesting to us. Looking at skill acquisition in gameplay, and so it's interesting. So I guess all of these things are kind of related to like skill and performance in esports, like focus, right? Like being able to kind of I guess be impervious to external distraction or whatnot, or to selectively attend to the important elements of the display. All of these are, I guess, areas of research that we are just fascinated by in terms of like what might be possible with BCI-based approaches. And so whether esports kind of drives the crossover into kind of like bringing it to the general population of gamers, or vice versa, right? I think that, yeah, we absolutely see that potential there. I'm very curious about the kinds of things we can uncover. And really it's just a general, I guess we want to understand how to push people up the skill curve as quickly as we can, and how people who are at the high end of the skill curve get there, and how they stay there. And if we can gain insight into that, then we can, I guess ideally broaden that, or broaden those perspectives or approaches out to everybody. So yeah, I think that our interest in esports and in multiplayer gaming kind of lends itself naturally to a lot of these sorts of questions, and it's definitely something we're going to be actively pushing forward as we go.
Thank you very much, everyone. I will stop here. We could go on for quite a while, but unfortunately, I want to be respectful of your time. I just want to remind everybody that we have the Neurobar. So if you hadn't have enough, we'll continue with the Neurobar. I obviously extend this invitation to the speakers. If you want to attend and interact with the audience, please feel free to join us in these breakout rooms. We'll be resuming we'll be having the Neurobar in 20 minutes at the hour. If you're in Montreal like me, it's at 3 p.m. Wherever you are in the world, it's a very different time. But at the hour, so in about 15-20 minutes. So please join me in taking all the speakers. I think that this was a fantastic event. Definitely there is a lot of interest. So we'll be doing, well, we have another one tomorrow, but definitely after that, we'll be doing more of these events. If there is any question specific that we didn't answer, we'll try to wrap them, pass them over to the speakers, and see how we can bring more value as possible, since the interest was quite overwhelming. So thanks to all the team as well, Slava, who's been pushing this, Brian, Sophie, Ilya, and all the team at Neurotech X. Thanks to the speaker, the audience, and I hope to see you to our next events. Thank you very much.
Thank you for having me.
Yeah, thank you for watching, guys. Thank you.
Thank you.
Have a great day, everyone.
Cheers.
Bye.
Bye.